Good morning, everybody. Good morning, everybody. Today, we're going to start about arithmetic progressions, lecture 2. So this is a series which we have started for the class 10 students, which is for the class 10 foundation series. So this is for the class 10 students who are appearing for various international level exams like Olympiads, KVPY, and whatever the exams that are competitive exams that they are writing. So in that, the first topic that we're going to talk about is arithmetic progressions. So today we started with arithmetic progressions in the yesterday's class, and just we'll have a recap from the yesterday's class. That is, what is a sequence? Sequence is nothing but a systematic arrangement of numbers according to a given rule. According to a given rule is called a sequence. Yesterday we had seen some examples, right? So yesterday we had seen, like for example, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So this is like a sequence which is repeating itself. Like after every next term, a new one is coming added into the ones place. So can I say this is 1, 11, 111, 1111, and this is 11,111, and so on. So this is a sequence. So here in the sequence, these are called the terms. So in this, whatever the numbers that are in the sequence, these are called terms. That is, this is the first term, second term, third term, and so on. Like the last term, which is the nth term of the sequence, it's given by Tn. This is called the nth term. Some people may call this as also the An. An is also the nth term. Some people denote it with Tn, and some people denote it with An. So like this. So this is called the general term of the sequence. So now what is arithmetic progressions? The arithmetic progressions is nothing but it's a number or the terms that are said to be in arithmetic progressions with when each one except the first one is obtained by adding the constant number to the previous or the other term, like we had seen. So like for example, the general term of an arithmetic progression that we have as like a plus d, a plus d, a plus 2d, and so on. If we see, we are adding a common difference, a d, or adding a fixed value, which is d to the previous term, except for the first term. The first term is a. The first term is a, and the second term is a plus d, and the third term is a plus 2d. So like that, if we go on, the tn will be, so the first term is a, second term is a plus d, third term a plus 2d, and so on. If you see, then what will be the tn or the an nth term? That is a plus n minus 1 times d. Am I correct? So this is what we have learned in the yesterday's class. Suppose if we see, so the nth term of the first sequence that is given by with the first term a and the common difference d is given by tn or an, that is nothing but a plus n minus 1 times d. This is very much important formula you need to remember, where a is the first term, n is the number of terms, and d is the common difference. Common difference. So I hope everybody from the yesterday's class, those who are there, they must know all this stuff. But the people who are came today as a fresh, so for them, just a small recap from the yesterday's class. Chalo. The next part of the topic is sum of the first n terms of an AP. So what is the first sum of n terms of an AP? So we have the general form of an AP, that is a plus a plus d, a plus 2d, and so on. So the nth term is also given by a plus n minus 1d. Correct? So the sum of first n terms of an AP will be, so sum is nothing but will represent the sum of first n terms as letter S. And from there onwards, we're going to add the each and every value. That is a, that is the first term we are adding. to that second term a plus d, third term that is a plus 3d, and so on up to a plus n minus 1 times d. Correct? Suppose if I rewrite this whole in the reverse order, so this is in the reverse order. If I write reverse order, if I rewrite this whole equation, that is s is equals to a plus d, a plus 3d, a plus 2d, and so on up to a plus n minus 1 into d. Suppose if I write it in this form, that is s is in the reverse order, that is a plus n minus 1 times d plus a times n minus 2 into d, and so on. Like if we go on, like it will be a plus d plus a. Now let us consider this as equation 1 and this as equation 2. So what we are getting, suppose if we add these both, like 1 plus 2, that will be getting 2s is equals to, if I add these both, I'll be getting 2a plus n minus 1 into d. So this and this I'll be getting, so that is 2a plus n minus 1 into d. Similarly 2a plus n minus 1 into d. So this and this I've added, a plus d, and this I've added. So similarly, if I started solving this, 2a plus n minus 1 into d, and so on. So everywhere I'll be getting, that is 2a plus n minus 1 into d. The final also will be the 2a plus n minus 1 into d. So how many times we are having? This is n times, right? N times we are writing this. So 2s can be written as n times of 2a plus n minus 1 into d, because suppose if I 1 plus 1 plus 1 plus 1 plus 1 plus so on up to n times if I had given, so can I write this as n, sum of all these terms, if I call this as s, so can I say s is equals to n? Can I say that? So similarly, we are applying the same concept here, where n into 2a plus n minus 1 into d, because the term is here 2a plus n minus 1 into d, it is recurring so many times. So that's the reason it's a formula. So the s is equals to n upon 2 into 2a plus n minus 1 into d. So what is the formula? So this is another important formula that you guys need to remember. So that's the important formula for sum of n terms of an AP. That is s is equals to n upon 2 into 2a plus n minus 1 into d. And one more thing. So apart from this, what we have seen, so Sn is equals to, so sum of n terms is given by Sn. So that is nothing but n upon 2 into 2a plus n minus 1 times d, correct? So if I expand this, can I also rewrite like this? That is Sf n upon 2 into a plus, so 2a can be written as a plus a, and rest all will be writing the same, a plus an minus 1 into d. So what is the tn that we have written? Tn or an, that is a plus n minus 1 into d, right? So this is the nth term. So nth term is nothing but a plus n minus 1 to d. So if we see this, so we are having the same thing. So can I write Sn in the form of n upon 2 into a plus n upon 2 into a plus an. So an is the nth term. So if it is an nth term, can I call that as a last term too? So can I call that as last term? If I represent the last term with the letter L, so n Sn is equals to n by 2 into, can I represent it as like n by 2 into a plus L? So this is what the sum of n terms of an AP. If we see, excuse me, so what are the terms, what are the formulas that we have got it here? Sum of n terms is equals to n upon 2 into 2a plus n minus 1 into d, or Sn is equals to n by 2 into a plus an, or Sn is equals to n by 2 into a plus l. See why I am emphasizing on the formula so much, because it is very much important to remember the formulas and understand the formulas, what we are using and when we are using. So if you remember all this stuff, the which is in the box, which is like almost every question can be solved. You just need to make out the puzzle. Chalo, we'll see one question based on this so that everybody understand the concept that we were taking. So, for example, Kanika was given her a pocket money on a Jan 1st, 2008. Correct? Kanika was given a pocket money on Jan 1st, 2008. She puts 1 rupee on day 1 and 2 rupees on day 2, 3 rupees on day 3, and continued till so on up till the end of the month. So, for example, if we see this, so can I say Kanika is keeping on the first day how much? 1 rupee. 1 rupee. Okay, 1 rupee. So, and so on, and the end of this month. Let us consider it is, what's the month they are saying? Continue till the end of the month from this money into her piggy bank. So she spent almost 204 rupees from a pocket money, and found that at the end of the month she still had 100 rupees with her. How much was her pocket money of this month? So everybody are asking. So let us consider the given month is January. So let the given month is January. Why we are taking January? Because it's the first month of the year, so we are taking. So how many days will be there? Number of days in January is, number of days in Jan are 31. So can I say first, for first day it is 1 rupee. So for the second day it is 2 rupees. Second day it is 2 rupees, 2 rupees, and so on. So till the third, so on up to the 31st day, how much rupees she'll deposit? She'll keep it in her piggy bank. That is 31 rupees. So now can I say, so what we are asking, how much money she collected. So how much money was her pocket money for the month? So that is 1. So next day she is keeping 2 rupees. So that sums up to 3 rupees till the second day. After that she sums up to the 3 rupees. Again 4 rupees, up to so on how many days? That is 31 days. So from here, can I say, is it forming an AP first of all? Let us check that. So can I say d is equals to 2 minus 1, which is equals to 3 minus 2? Yes, that is equals to 1. So that is our common difference. And what is the first term of an AP? That is 1 now. So we got this. So we have the last term, which is equals to L, that is 31. We can say L is the 31. So can I say S31 can be written as, this can be done in two ways. The first method is n upon 2 into 2a plus n minus 1 into d. Or the other one, S31 is equals to n upon 2 into a plus l. So that is 31 upon 2. What is the first term? 2a, that is 2 times 1, and 31 minus 1 times d, which is equals to 31 by 2, that is 31 upon 2 into 2 times 30 into 1, because d is 1. So that is 31 upon 2 into 32. That is 16. So 31 times 16 is nothing but 496 rupees. So we got this. So 496 is the sum of all the values. So now they're asking again, suppose if we apply this formula, so what we'll be getting? Same thing. That is 31 upon 2 into, what is the A? That is 1. L is 31. That is 31 upon 2 into 32. That is 2 ones to 16. That sums up to 496. So I hope everybody understood this. So this is half of the question. So now they were asking, she also spent 204 rupees. Yeah, there's a kid, so they'll be generally spending some money. So they're asking 204 rupees they spent. So can we say this? So she spent 304, sorry, she spent 204 rupees. She spent 204 rupees, and the money she had is 100 rupees. She had in her pocket, that is 100 rupees. So what is the total money we got? That is 496. So if you see the 496, that is 496 she's having. So what's the money that she spent? That is 204 rupees she spent. And what's the money that she had now? That is 100 rupees. Apart from this, she spent those money. So can we say this is equals to 496 plus 204 plus 100. So this sums up to some value, right? That is, we'll add up and we'll say this is 800. So can I say the 800 is the pocket money of the girl that she had saving her money? That is Kanika. So what's the total money she had? What was the pocket money for her month? That is 800 is the pocket money. So I hope this is a bit more clearer. So we'll go to a bit lesser level of a problem so that everybody understood the formula again. So they're asking some of the first 22 terms of the AP is given. So AP they वो लोग दे दिया है, that is AP has been given. So the first term is A, 8. The second term is 3. So to get that common difference D, that is A2 minus A1, this is 3 minus 8. That is minus 5. So now everybody understood. So everybody must be getting a panic situation. Why? Because it is D is minus 5. So if D is minus 5, that's not a problem. If we add minus 1 with a minus 1, we'll be getting minus 2, right? We'll be getting some negative value, not as a positive value. So that's not an issue here. So let us understand. So we got the D as minus 5. So A as the first term A1 or A, which is equals to 8, and we need to find the value of sum of first 22 terms. So we got the N also, that is N is 22. So we got this. So what's the formula? Sn, that is N upon 2. Let us write the formula itself. So let's write the formula. That is Sn is equals to N upon 2 into 2a plus n minus 1 times d. So here n is also given, that is 22. So that is S22 is equals to 22 upon 2 into 2 times of 8 plus 22 minus 1 times d, that is minus 5. So 2 ones to 11. So yeah, 11. So 8 to 16 plus 22 minus 1 is 21 times minus 5. So I hope everybody understood this one. Yes. So this is minus 5. So this is equals to 11 times of 16 minus 105. What is the value of 16 minus 105? Okay. 11 times of minus 89. So what is the value of 11 times minus 89? So 89 times 11, that is 19, 8, 9, and 8. That is 979. That is minus 979 is the sum of first 22 terms of an AP, that is 8, 3, minus 2, and so on. So I hope sum of n terms everybody understood this concept. So we'll be solving some more problems based on the yesterday's class. So we'll be solving some, like for example this question, that is determine an AP whose third term is 5 and the seventh term is 9. The third term is 5 and the seventh term is 9. So any guesses how to do this? I'll give like a couple of minutes of time. So if you can solve, it's good. You can solve this question and we can discuss the answer. So determine an AP whose third term is 5 and the seventh term is 9. Okay, so let's start. So A3 is given by 5, and in the seventh term is given as 9. And we know A3 can be written as A plus 2D. How can we write this? Because we know AN is equals to A plus N minus 1 into D. AN or TN we can say. So we are asking A3, right? So N value is 3 in the first case. That is A plus 3 minus 1 into D. That's we've known. So A plus 2D is equals to 5. So that's how we got A plus 2D. So what is the value of A7? That is A plus 6D. A plus 6D, that is equals to 9. So can I say they were given this values? So A plus 2D and A plus 6D, which is equals to 5 and 9. If we subtract these values, what is the value we are getting? Why we are subtracting is nothing but now it is a linear equation in two variables. Linear equation in two variables. I hope in the last year, so many of you have done this particular concept. So this is not a problem. Two variables. So what are the variables here? Two variables. What are the variables? A and D. So if we subtract this, so 6 minus 2 is minus 4. Minus 4D and minus 4. 9 minus 5. So D is equals to 1. So we got a difference now. So if we plug in this D value in any one of the equation, let us consider this as equation 1 and this as equation 2. If I substitute D is equals to 1 in equation 1, that is A plus 2 times of 1 is equals to 5. That is A is equals to 5 minus 2. So the first term is 3. So we got the first term. So we got the A and we got the D. So from here we can find the AP now. So what is the general form of an AP? A plus D, A plus 2D, A plus 3D, and so on. So what is the A? That is 3, 3 plus 1, 3 plus 2 times of 1, 3 plus 3 times of 1, and so on. So if you see 3, 3 plus 1 is 4, 3 plus 2 is 5, so 3 plus 3 is 6, and so on. So this will be the AP. So I hope this example is clear on how to solve an AP when any two terms are given in the AP. So next question. Find the 11th term from the last term towards the first term of an AP, that is 10, 7, 4, and minus 62. So any guesses how to solve this question? Find the 11th term from the last term. Just guess. So try. Let's see the answer. So what is the AP that is given? This is 10 minus 4. So here's the AP that is given. So from here, what is the first term? That is 10. What is the difference? That is 7 minus 10. So it is minus 3. Now what we need to find? We need to find the 11th term from the last term of which the AP is 62. So first we need to find the which term is minus 62. This is one term, we need to find its value n. हमको n ढूंढना है. So n, to find the n, what is the value? So can I say an is minus 62? Because that's the last term, we know that. So n ढूंढना है. So an is given by a plus n minus 1 times t, and in this we don't know only the n, we know the value of a, we know the value of d, and we know the value of an. So minus 62 is equals to 10 times, 10 plus n minus 1 times minus 3. That is minus 62 minus 10 is equals to minus 3 times of n minus 1, that is n minus 1 upon minus 3 is equals to, okay, plus 3. So if we take the minus and minus common, it will become the whole plus. So it will be 72. So n minus 1 is equals to 72 upon 3. That is 3 ones, 3 twos are 6, 3 fours are 12. So n is equals to 25. So this is the 25 terms. So there are 25 terms in the given AP. So now what they are asking, find the 11th term from the last. So 11th term from the last क्या होता है? That is 11th term from the last. So last से करेंगे तो there are 25 terms. From that, if I do the minus 10, so I'll be getting the 10th term. Correct? How we got this? So what is the last term? Last term is 25th. So what is the second last? Second last देखेंगे तो 25 minus 1, that is 24th term. Third last क्या होगा? Third last is equals to 25 minus 2. So what is the nth term from the last? That is nth term from last. So can I say this? Now, for example, there are 25th term. Let us consider that is a 25 term. So 25 minus of n minus 1. So that's how we got this 25 minus 10th term. So 25 minus 10 is the 15th term. So to find the 15th term, that is A15 we need to find. So n is known, everything is known. So A is 10 plus n is what? 15 minus 1 times D, that is minus 3. That is 10 minus, so 10 plus of 14 minus 3. That is 42. 10 minus of 42. Answer is minus 32 is the term. So minus 32 is the term. So minus 32 is the term from the last towards the first term. So 11th term from the last term towards the first term of the AP. So minus 32 is the last term from the AP. So I hope everybody understood this. So this is the last 11th term from the last or 15th term from first of an AP. Hope this is also clear, and we'll start with the next question. In a flower bed, there are 23 rose plants. In the first row, 23 rose plants in the first row. And no, these are the plants. Like let us consider this is plant. They say there are 21. So on up to 20, 23 here, 23. And in the second row, there are 21. And so on, there are 21. And similarly, and 19 and so on. So ऐसे करेंगे तो so on up to 19. So if we go on this, so if we keep these numbers in a straight line, that is 23, 21, 19, and so on. Is there any number that we are getting common? If we see 21 minus 23, what is that value? Minus 2. 19 minus 21, we are getting a minus 2. Yeah. Now we can say that it is having a common difference of minus 2. So that we can call them as an AP. So why we are calling an AP? Because it is having a common difference. That is minus 2. I hope this is clear now why we are calling this as an AP. So now this is what we got. So it is an AP now. So now what we need to find? There are 5 rose plants in the plant from the last row. So in the last row there are only 5 plants. So can I say nth term is the 5 now? So we got the nth term. So what we have in our hands? A is equals to 23. D is equals to minus 2. Okay. A is equals to 23. D is equals to minus 2. And AN is equals to 5. What we need to find? The value of n. So what is the value of, what is the formula for an? A plus n minus 1 times d. So what is the value of an? That is 5. What is the value of a? That is 23. N we need to find, n minus 1 times d is minus 2. So n minus 1 times minus 2 is equals to 5 minus 23. So that is n minus 1 divided by minus 2 is equals to minus 18. So n minus 1 is equals to minus 18 upon minus 2. Minus minus cancel, 2 ones are and 2 nines are. If I solve this, that is n is equals to 9 plus 1, which is equals to n is equals to 10. From this, what I can say, therefore there are 10 rows in the flower bed. तो ऐसे देखेंगे तो there are 10 rows. Everybody understood? आपको समझ में आया how important this formula is now? चलो, we'll see some more questions. Two APs having the same common difference. So PIP, दो AP का common difference same ही है. Two APs having a common difference same. So the difference between their hundredths term is 100, and what is the difference between? So let us consider two APs as A1, one AP, and A2 as another AP. Okay, so now both of them are having, suppose consider the AN of this AP will be AN1 will be A plus A1 plus okay. Oh, I don't know. So we know that an is given by a plus n minus 1 times d. Yes. So the 100th term क्या होगा? 100th